let us start off with the presentation. Right. So if you can see the title slide, it is written Object-Oriented Methodologies Introduction.
Yes, sir.
Right. So the subject we are going to study is object-oriented methodologies. Now, you people must have already heard somewhere or the other that there is something called object-oriented programming, and I'm sure most of you must be knowing about it in great detail. So I am not here to challenge your knowledge. In fact, I am just here to help you make sure that what I know and what you know are the same things. Okay. Moving ahead, we will take a look at something called POP, POP, right? So it stands for procedure oriented programming. As you can see here, it stands for procedure oriented programming. Now, it will become clear to you in a few minutes why we are going through all this trouble. But let us try and understand what procedure oriented programming is all about. So in POP, every problem is treated as a sequence of things to be done, right? So till now, whatever programming that we have gone through using C programming or others, in all those cases, we have treated any particular problem as a sequence of things to be done. So there is a sequence of instructions and we are supposed to follow it, right? So again, every set of such instructions is grouped into a separate function. And the primary focus in procedure-oriented programming is on functions. Obviously, the word procedure corresponds to the word function, right? Procedure, method, all of these are other words for functions. So this is all about the basics of procedure-oriented programming. Now, if we try to sum up what it gives us a list of instructions that we have to follow word by word, and the related set of instructions are grouped together as functions. So let's say I have a set of 10 instructions that can help me find out the compound interest for a given principal, rate and time, right? We all know what compound interest is. So let's say I have a set of instructions, 10 instructions, let's say, which help me find out the compound interest with a given set of principal, rate and time, right? So what we did is, or what we can do is, we can group those set of 10 instructions under a single function called compound interest or some other name. That is how procedure oriented programming works. The most important thing to note here is that there is a flow of control from one function to another. So there is an initial function which calls another function, which in turn may call another function, and this can go on. The main focus in procedure oriented programming is on functions. There is little attention given to the data. This is another important thing that we have to understand, right? The main focus in procedure oriented programming is on functions. There is little attention given to the data. So it may appear to you that sir kuch bhi bole ja raha hai, samajh mein nahi aa raha hai. The point is we will get to understand why we are going through this right now. So we have already seen this sort of a structure, we hope.
Yes, sir.
Right. So could you just type in the chat box where we have seen this sort of a structure? What kind of programming language we have found this main program which calls another function, which function may call another function, or the main program may call function 4, and this goes on. There is a flow chart which starts with the main program. This sort of a flow chart we follow in a particular programming language. Can you name that? We have seen this sort of a structure in the C programming language, right? So in the C programming language, we have something called the main function. Okay, so there is a main function which we have to keep. We are always told that we have to keep a main function in the C programming language. Now, the main function may require the calling of other functions, function 1, function 2, function 3, function 4, function 5, whatever. So it may so happen that main program calls function 1 and function 1 calls function 4. or it may so happen as per our requirement that the main program directly calls function 4, right? So this sort of a flow is called a top-down approach. As you can see on the left side of the screen here, we have written that this sort of a flow of control is called a top-down approach, right? Right. So there is something called treatment of data in procedure-oriented programming, right? So how is the data treated in procedure-oriented programming? That part we have not yet focused on. So see, it is written, many important data items are kept global. Now we have already learned what the local scope is and what is a global scope for a variable, right? So whenever we define any variable outside the main function, right, that generally we call, that we said is having a global scope, right? And local scope is said for those variables which are kept within the main function or within a specific function, right? So most of the times what we have seen is, or what we have learned is, that a variable with local scope, that is a variable that belongs to one particular function, it is not available to the other functions, right? So that gives us a lot of trouble while we are programming C. So to make things simple, what we have been doing is, we have been keeping things at a global scope. That makes things accessible to all the functions, right? We have already done that more or less. So what is the issue with this? The issue is that such variables are prone to inadvertent change by functions. The word inadvertent here means the one that I don't expect. There could be places, there could be situations where the value of these global variables is being changed, right? And it may be changed without my liking, right? I may have written a particular function which is changing the value in such a way that it is affecting the working of another function, right? And I may not be liking that. Fine. So this is one part which is not troublesome for us while we are working on short programs, but while we are working on programs of larger length which consists of multiple functions, in that case it becomes quite troublesome to maintain and ensure that variables with global scope are not changed without my liking, right? It is very difficult. So in that case we need to have a solution, right? Before going to the exact solution, let us see how the data and functions interact. So in a large program, it is difficult to track which data is used or modified by which function, right? We could say that this structure shows us that we have two global data elements, global data 1, global data 2, right? And we have three functions, function 1 and function 2. They have their own local data values, right? Function 1 and function 2, they have their own local data values. Function 3 does not have its own local data, and that is quite possible. All of these functions make use of global data 1 and global data 2, right? So what I'm trying to highlight it may so happen that function 3 needs to modify global data 1 or global data 2. Now in such a case, keeping it as a constant would not actually make my work easier, because maybe function 2 and function 3 just need to access the global data and work with their local data. But it may so happen that function 3 has no local data and it needs to work with and modify global data, right? So there are many such scenarios where keeping a variable as constant, or keeping a global data variable accessible for all the functions may lead to multiple problems. So next we will move ahead and we will try to understand, we will try to just get introduced to something that can help us take care of similar problems. Okay, so some observations. So it is said that the functions are action oriented, right? This part is very important to note. Whenever we have functions, the functions are only concerned with making something happen, right? So there is a particular function which can add two numbers. A particular function can compound the simple interest, can calculate the simple interest. A particular function can calculate the compound interest, and so on, right? So functions are always action oriented. And in procedure oriented programming, the focus is on functions, that you can easily understand from the name itself, because the name contains the word procedure, right? Now it is said that such approach is difficult uh, when we are trying to model the real world elements of any problem statement, right? So it is said that this sort of approach is difficult to use when we are trying to model the real world elements of any problem statement. Now why is it difficult, and how are we going to take care of this difficulty, that we will see in the upcoming lectures, right, in a few days. But right now, uh, you can imagine that given a particular real world problem, right, which corresponds with what or how we are interacting in the real world, for that we can only work with particular variables which represent the real world values, and then we have to define functions which can work with those real world values, right? So there is no other way of modeling the real world interactions between different data elements, right? So if I have, let's say I have a book, right, and I have my laptop, and both of these are real world elements. Now how the book works, or how, what is the functionality, or what is the character of a book, what is the character of my laptop, all of these things I cannot actually characterize using procedure oriented programming. In procedure oriented programming, what I can do is I can write a function called how book works. I can write a function called how my laptop works, and then I can make those functions print something, right? A book contains pages, a laptop contains particular programming language codes, etc., etc., softwares, and all that. But the real world modeling of the data elements is not actually possible in the procedure oriented programming. For that, we need a outlet, right? We need a place, a freedom where we can actually try to model how the real world elements are interacting between themselves, right? For that, uh, there is a solution, right? These laws in procedure oriented programming motivated the development of object oriented programming, which we also refer to as OOP, right? So previously we had POP, now we have OOP. Fine. So what is all about object oriented programming? So today we will simply just barely scratch the surface of what object oriented programming is, and day by day we will go deeper and deeper into the concepts of object oriented programming, right? So first and foremost, there was a primary concern when we were going through procedure oriented programming, that the data is global, and as the Borup said, we could treat it as constant, but in that case there would be functions which could not maybe modify the data even if I was wanting it to modify, right? So there were multiple problems. So in object oriented programming, the main focus is on data. Okay, so data is critical, and it is not allowed to flow freely in the program, right? So data is treated as critical. It is not allowed to flow freely in the program. Data is also tied closely to the functions that use it. So this would seem like something like having local data, right? Local variables, not global variables, and they are tied closely to the functions. Now, how are they tied? That we would also come to. Also, data is protected from modifications by unrelated functions. So this is one permission, or this is one power that we have in object oriented programming. We can actually ensure that the unrelated functions do not get to protect, do not get to modify the data. The data is actually protected from unwanted modifications, right, by unrelated functions. So this is the whole focus point of object oriented programming. The whole focus is on the data, right, and not on the functions. So how does object oriented programming work? So it is said that every real world problem is decomposed into objects, right? Every real world problem is decomposed into objects. Objects have distinct and independent existence, right? So my laptop has a distinct and independent existence. Your mobile phone has a distinct and independent existence, right? My book has a distinct and independent existence, and so on and so forth. Each and every object in this universe, in the real life, has a distinct and independent existence, right? It is not dependent on any other object. Similarly, in the very same way, in object-oriented programming, we can work with real-world objects, and we also call them objects, right? And each of these objects consist of related data and functions, right? So each object has its own related data, some values that it can deal with, and some particular functions which help us understand how the object works. In the previous case of procedure oriented programming, I use the term characterize, right? So actually these data and functions help me characterize the object, right? So if you can just try and imagine, when we are trying to work, when we are trying to write a program and try to work with my laptop, try to model the real world problem of my laptop in a programming statement, in a object oriented programming statement, I could very well characterize it, right, by using some data values and some particular functions which are associated with those data values, right? So going into a bit more details, let us go through the features, the salient features of object-oriented programming. So as I have already said, the emphasis is on the data, not procedures or functions, right? So unlike procedure-oriented programming, the emphasis is on the data. The programs are divided. See, the programs are divided into entities or objects. In the previous case of procedure-oriented programming, what we had was the programs were divided into procedures or functions, and it was a top-down approach, right? Here, the programs are divided into entities or objects. Data structures. Data structures are designed that characterize the object. See, there are particular data structures which we will come to in the next lecture, in the next class, right? And these data structures are called class. There is something called a class. And actually, these class data structures, they are designed so that we can efficiently characterize how particular real world objects work. Fine. And the functions that use the object's data are tied together in the data structure. So basically what this means is the data structure called class, it helps us tie together the functions and the data elements which help us characterize any object in object oriented programming. Now, once you try to understand the essence of how object oriented programming works, I'm just trying to do that, right? Practical implementations we will always go through, no doubt, but right now you all have to try and understand what is the benefit of learning object oriented programming. And I'm quite sure once you grasp the concept of object oriented programming, you will not actually tend to go back, and work with procedure oriented programming. Anyway, so moving ahead, there are other features again. Data is hidden and it cannot be accessed by external functions. This is another very important feature. So data is kept hidden by default and it is not easily accessible by any external functions. Each object can intercommunicate with the use of functions. So if I have the real world problem of my laptop and my mobile phone and my book modeled using object oriented programming, I can actually make these objects intercommunicate, right? I can make these objects intercommunicate using functions. There is also the ability to add new data and functions as required. So that will obviously be required because we are trying to model real world problems, right? And like in the real world, here also we may need to work with newer and newer data and functions. The last thing right now is that bottom up approach is followed. It is called a bottom up approach. So in the previous case of procedure oriented programming, we have already seen that it was written that it's a top down approach. So always it starts with the flow of control begins with the main function, and from that we move on to other different functions which call each other, right? So that was a top down approach. But right now in object oriented programming, we follow a bottom up approach, right? So let's take a look at it. So this is a typical structure of object oriented programming. So as we can see, we have object A, we have object B, we have object C, right? We have three objects right now. We could have n number of objects. There is no actual limitation, fine. And as you can see, each object has its own space, right? As you can see, each object, like object A has its own space. Object B has its own space. Object C has its own space in memory, right? And each object has its own particular data that it can work with, and it has particular functions which can use this data. So as you can very easily note, there is one very important observation to be made here that we will come to next. That is, each object's function can work with its own data. So the function in object A or the functions in object A can only work with the data in object A. The functions in object A cannot access the data in object B. That is not allowed, right? So this is a very important observation that you need to make. See, we have written a comment. Different objects consist of bundled data and functions. So the data and functions are bundled together or bound together in a single unit inside the objects. So object A has the bundled data and functions. Same thing for object B and same thing for object C, right? Next, see, now we have another important thing to note, that the functions of different objects can intercommunicate, whereas the data values are hidden from outer functions. So object A's function can intercommunicate with object B's function, which in turn can intercommunicate with object C's function. So all of these functions can intercommunicate. They can keep intercommunicating, but none of them can access the data value of another object, right? The function of object A cannot access the data of object B. Similarly, the function of object B cannot access the data of object C, and the function of object C cannot access the data of object A. This is very important to note, right? So each object's functions, they can always intercommunicate, whereas the data values are kept completely hidden from the functions. Fine. So am I clear up to this part? I would love to see yes or a no in the chat box. Please respond. Am I clear up to this part? Okay. Okay, that's great. Thank you. Okay, so we have almost, finished with our introductory lecture. We have just 1 or 2 slides left, and then we will move in towards more informal communication. Okay, fine. So let's come to a formal definition. Now, we all know that whenever we are working with some theoretical subject, right, we always have to write down, or we always have to try and understand some boring definitions that the teachers are expecting from us, and we are expected to write that down in order to get marks, right? So here also we will go through a formal definition that says that object-oriented programming. Now this is a definition for object-oriented programming. Okay, it says that object-oriented programming is an approach. Fine. So this is something that we don't need to mug up. This we can easily write down by remembering. It's an approach. Very good. That provides a way of modularizing programs. Right? So object-oriented programming is an approach which provides us with a way of modularizing programs. So given any particular huge program, we can modularize it. What does modularizing mean? It means breaking it down into small parts so that we can efficiently handle the problem, right? So we can efficiently handle the problem. Now, each of these modules can be thought of as a particular object, right? So it's an approach that provides a way of modularizing the programs by creating partitioned memory area for data and functions. Fine. So this is the third point. The first point was that object-oriented programming is an approach. The second point was that it provides us with a way of modularizing programs or breaking it down into easier and simpler parts, right? The third point is, how do we modularize it? We modularize it by creating partitioned memory area for data and functions, right? Now, in order to understand this statement, creating partitioned memory area for data and functions, let us simply go back to this diagram once again. So here we can see object A has its own data and its own functions. Similarly, object B has its own data and own functions. Same thing for object C. So object A and object B and object C, all of these do not have any overlap. Also, you can very easily guess that whenever we are working with object A, it is allocated some particular space in memory, which is not the same as the space allocated to object B. which in turn is not the same as the space allocated to object C, and so on, right? So each object has its own particular space in memory. That is very common sense, right? That's a common logic. So again, if we come back to this, so creating partition memory area for data and functions essentially represents that we have particular unique memory spaces or partition memory areas for objects, right? So again, we can say that we have an approach, a new approach, which provides a means of modularizing the given programs by creating partition memory areas for objects. Objects consist of data and functions. So we create partition memory area for data and functions. I hope this point is clear. Now, these partition memory areas, these modules or these objects, they can be used as templates for creating copies on demand, right? So when I have a particular object which represents my laptop, I can simply, if required, create a copy of that object, right? And I could make it correspond to Ayush's laptop, right? I could simply make it correspond to Ayush's laptop. Again, if I have a particular object which represents my mobile phone, I could simply make it correspond to, let's say, Shubhroshil's mobile phone, right? And that is how object-oriented programming helps me model the real world in a very, very easy manner, right? So again, if we take a look at the whole formal definition part, because this you're supposed to write in any examination, fine? So you're very, it is very crucial that you understand what this says. So we will just break this out into 4 parts. The first part is object-oriented programming is an approach, and that's all. The second thing is this approach provides us with a way of modularizing the programs, right? So object-oriented programming provides us with a way of modularizing the programs. This we have already understood. It helps us break the program into simpler, smaller parts. How? We can break it out into modules by creating partitioned memory areas for data and functions. That is, the word is objects, but right now in the definition, we will not use the word objects. We will write by creating partition memory area, which are not overlapping, right? They are partitioned memory areas for data and functions. And this is the third point. And the fourth point is that these can be used as templates for creating copies on demand. Now, as I already said, the object created for my laptop can be copied in order to provide or in order to characterize the laptop that is owned by Ayush or Shubhronil's mobile, right? And I can keep doing that as long as I want. And each copy will have its own partitioned memory area using its own data and functions. This is the formal definition of object-oriented programming, and I am very hopeful that you people will not require, copying or mugging this up, because this is quite simple to understand, right? Okay, we have come to the last slide of our lecture. Fine. So, and this slide says that an individual object is a partitioned area in computer memory. See, an individual object is a partitioned area in computer memory. This we have already understood. Very good. This partitioned area stores the data and set of instructions that can use the data. And these set of instructions that can use the data, we call them the functions, right? So this is all about the summary of object-oriented programming that we have learned today. So an individual object is nothing but a partitioned area in computer's memory. And this partitioned area stores the data and the instructions that can use the data. These set of instructions are also called the functions, which are bound with the data. See, that is why when we were going through this diagram, we had told you that every object consists of its own data and functions. Every object consists of its own data and functions. So this is what the statement means, right? So every partitioned area consists of the data and the instructions kept in the form of functions. Okay, the last point is, as the partitions are independent, the same objects can be used in different programs whenever required. As the partitions are independent, the same objects can be used in different programs. We just need to know, we just need to understand how we can reuse these objects using proper syntax. That's all, right? So it may so happen that I am working on a particular real life problem which requires me to characterize my laptop. It may also happen that Ayush needs to write a program where he needs to characterize his own laptop. In that case, he may simply take my piece of code, he may simply use the object that I have used in my program and use it in its own program with its own characteristics. Object oriented programming makes the whole problem of modeling real life situations that simple. Okay, so I am hopeful that this short presentation was helpful in understanding the basics, the nitty-gritties of object-oriented programming. And in any case, if you have any doubts, you can simply ask right now. Okay, so I will be stopping the recording, and you can feel free to ask any questions. Right? Okay.